All right. So talking about the slope stability today with MIDAS GTS. All right. So we're gonna have an overview and then showing you the model and running the different type of analysis. Let me. Okay. Now you guys can see the screen. All right. So in general, the reason we are doing this slope stability is to find out if a part of a bank of soil is stable enough or not for different type of loading or situation. Like when we have the groundwater, when we have external loading added to the structure or the ground, or when we have the earthquake. So this instability may happen based on the self-weight or any external loads. So technically, when the shear stresses, which comes from the other sources, goes beyond the shear strength of the that particle of soil, definitely we're gonna have the shear failure. So we are checking exactly this one. So there are different methods for doing the analysis and find out if this ground is stable or is not. So the well-known methods are finite element methods and also conventional traditional methods called LEM or limit equilibrium methods. So the LEM method is technically based on the slices where we come up with some assumptions and divide the ground or the slope into smaller pieces and then doing some simple analysis and finding out the shears, and then based on those we calculate the safety factors. So the final destination or final purpose of these analysis for slope stability analysis is to find out the safety factors to see if it's good enough and if it's satisfies the design codes or not. Then we have other methods like SAM, which is stress analysis method. In this method, the limit equilibrium method is applied to a state of stress in static equilibrium computed using a nonlinear finite element. So it's a kind of combination of the finite element and those conventional methods. And then we have the finite element method, which we call it SRM or strength reduction method, and that's technically based on the finite element modeling. Okay, so this is what we discussed. If we have like this part of ground, like a slope shape, it can fail based on the slope failure surface, and the shear stress goes beyond the shear strength, and then we got the failure. And this is the slope. The safety factor that we calculate would be S divided by T. So strength divided by the existing stress to calculate the safety factor. All right. So this is this diagram showing you how the LEM method works. So most of the conventional software are using the LEM method, which is pretty basic and but giving you a good result. Therefore, it's very popular amongst the geotechnical engineers. But in the LEM method, it just gives you the safety factor is okay, but you really cannot investigate local failure or displacement. So it's not. It has really so much limitation. And then there are a lot of assumptions are coming into equations, and then it can make your design pretty conservative and sometimes not cost effective. So you sometimes need to use better tools or more accurate tools to calculate them. Then again, we have the finite element methods like a SRM method, in which we calculate, imagine starting by a strength line, and then we just by the trial and error going down and down until this line is reaching this Mohr circle, and then that's the point of the failure. So based on that, we can simply calculate the safety factor. And finally, when we got the safety factors, then we can compare them with the what code requires us, and then we can see this completely depends on the code what you are using, and then in a different situation, definitely different safety factors are required. So these examples are from the US code. So that's a general information about the slope stability analysis. Now, what I prepared for you is that I got this tutorial where we have this embankment here and this is slope. I wanna run model a 3D model for you, mesh it, and then run the slope stability analysis. In MIDAS GTS, you have option for doing the slope stability both for 2D and 3D. Okay, for 3D, you can only use the finite element analysis, because what we just talked about the LEM method. LEM method is limited to 2D analysis. So we in MIDAS GTS we also use it for 2D analysis, and we'll go with the SAM or stress analysis method. While for 3D we only go with the finite element methods, and then you see how their results look like. So this will be our final destination or final model. And what I do, I will start modeling this one by one. Step by step, and starting from scratch, defining the material property, defining the geometry. I will show you how you can control the mesh size. For example, if you see here, we have smaller mesh or finer mesh around this area, and then we have coarse mesh outside. So I show you how to control the mesh. I'll show you how to create any type of geometry. So here we have intersection of these two type of geometry, and how to apply the boundaries, and how to set up the analysis. Again, if you got any questions, please just stop me, and let's discuss it in more detail. Okay, so let me just open a new GTS. And again, if you want to go into 2D, MIDAS GTS, a good thing about MIDAS GTS is both 2D and 3D are in the same package, and then you can use them, use either one that is more suitable to your project. Okay, so let me start creating the geometry. So for now, we have the 3D model. Okay, so whatever we have when we model in the model view, you can see them in under the tree menu. So we have three tabs for whom are new to the MIDAS GTS. I'm just trying to explain as much as I can. We have three tabs: model, analysis, and post. So the model will be whatever we do the modeling. Analysis is for loads, boundary conditions, and analysis, and then post will be for results. So we start with the model. So first of all, let me set up my unit. So I wanna set it up to the SI unit. So I go with the kilonewton and meter. Okay, and I will share this tutorial with you so you can practice it yourself as well if you are interested. Alright, so we can go to the properties. So I see a question from Gizel says, what about the mesh? Until how many number of lines can I create? There is no limitation on the number of mesh or number of line that you wanna use. Number of line for creating the geometry, and number of mesh for meshing your structure, your model. So I don't have any exact number for you. There is no limitation for that actually. Okay. So let me define some attributes. So we go to the ground, solid, and add. This time I'm trying to make a clay. Define the material, calling matte clay. And we can enter the modulus of elasticity as 1.5e to the power 5, and Poisson ratio 0.5 is okay. Unit weight, (20 kilonewton), and saturated unit weight again 20 kilonewton. For cohesion, I go with the, let me select the more Coulomb. Cohesion, I'll go with the 20, and friction angle of 30 degrees. Alright, so for now, let's go with the, more Coulomb, and just keep it as is. Alright, so I define the math foundation here. Now I go with the drained, and for the tensile strength, I wanna just give some number like 1 to the e to 7 kilonewton per square meter, and okay. Alright, so my more Coulomb is created. Now I call it clay. Alright, and okay. So now first we created a one attribute, so we're gonna use them when we go into the modeling. Alright, so now I want to create that geometry. What I do, I first create it in 2D and then extrude it into 3D. So this is very easy. If you guys have the let's say the section in 2D or 3D in AutoCAD, so you can simply save it as DXF file, and then here you can go to the file, import, and then DXF 2D and 3D. Both of them are available. So you can just simply, let's say 2D, you just click on that and select the DXF file and import it. It's that easy. But here I don't have that. So what I do, I start creating the geometry. Oh, Giselle, again, Giselle asked a question again, how many blocks of finite element can I create? So you can have as many as you want. So we call them mesh. You can mesh the solid, plate element, or line element, all three type of finite elements. And again, there is no limitation on a number of them. But the more that you now create, definitely your model going to be heavier and takes more time to run the analysis. Alright, so let me start creating the geometry. So for that, I go to the 2D, so I can simply click on this and creating 3D. Okay, that's fine, in the Z direction. So I start going with the polyline for 2D. So click on that. As I said, I'm going to create the 2D first and then extend it to 3D. Ensure that the dimension is on the meter. So I start with the location 0 and 0, then enter, and then you see the method automatically changes to relative. But if you want to apply the next node, if you know the exact coordinate of that node, you can go with the absolute. Or you can go with the relative if you want to just relatively give the distance from this point. So I'm going with the relatives, so therefore I'm putting on the relative. So the next point would be 47 in the x direction. and 0. So for entering the dimensions for x and y, we can either enter comma or just a space. Enter. Then again 0 and 5. So we are going up. Then again negative 15 and 0. Enter. Negative 20 and 10. Enter. Negative 12 and 0. Enter. 0 and negative 15. Enter. Alright, so this is created, and close it. And if I go to the disk view, you can see that my base geometry is created. Now if I go to the 3D view, you still see that this is in a 2D model, so I have to just extrude it into 3D. So to extrude it, I can simply go to the solid, and then click on this option, extrude. Select the extrude profile. You can set it up on the wire, because whatever we created here is only wire as of now. And then select the extrusion direction. I can simply select the Z direction, because I know that I'm going into the this plane, so it's going to be that direction. And now the length will be 25. Before you hit OK or apply, you can just get the preview. So this icon here, if you click on that, it shows you that how the final shape going to be. So this is exactly what I wanted. So I can simply enter it. So, and I can give it a name. Let's say Model 1, and OK. Alright, so so far I created a 3D geometry. So if this grid line also is in your way and does block your view, you can simply click on this and it goes away. Alright. Let me check the questions. Alright, Giselle, you asked what other files. So you can go to the file, and then in the import you can see all different type of formats. Then you can import into Midas. So I can tell you later on. We can just go through them one by one and tell you which one is good for what. Alright. So the next step would be creating that edge here. So for that one, I start changing my working plane. So we have one option called working plane, which, as you can see here, this is the grid line, and that actually helping me to in the modeling. So if I want to use any of these curves in the 2D or selecting any nodes in 2D, I should be in a working plane. So what can I do? I can simply switch the working plane in a different location, just to locally work on that location. So that's really making my life easier. And the point is, we are not changing the global coordinate system or the local coordinate system. We are just changing the working plane. So how to change the working plane? For example, I want to work in top of this slope. What can I do? I can simply click on this option, move work plane, and I can select the 3 points. Point 1 will be the center of this, point 2 will be here, and point 3 will be right here. So technically point 1 to point 2, get the preview, this is exactly what I want, and OK. So this time if I click on this, it just take me to the top of the page. OK, so let's move on and create some working plane again. So you can technically use these options here, use these icons from, let's say, curve, surfaces, and solid, or you can go through the main menu. Either one you feel more comfortable with. So let me just work with the main menu. Then you have options. You see that how different options could be used in the software. So I go to the geometry, and then curve, and then create a working plane, and then polyline, or the wire. Okay, I select that. That's exactly the same thing that I used here. So by clicking one icon over here, you have to go different path. It all depends on you. All right, so let me start this again. This time I will start from negative 2.5 because I know that's the right middle of my point, and say enter and put the so the next part will be 2.5 and negative 10, enter. The next one will be 2.5 and 10, enter, and finally negative 5 and 0, enter. Okay, cancel. And this one is created. I can go to the 3D view and then see that there is an additional curve created here. So now what can I do? I can just extrude it again. Alright, going to the solid and extrude, and we can simply select the wire. You see I'm changing the options from this menu. But whenever you come in here, I mean, you need to select something. So it could be a wire, it could be an edge, it could be a face, it could be a solid, it could be a mesh. Based on the type of function that you are using at that time, the corresponding or the available options for you will be listed here. So for example, in this method for extrude, I can select either face or wire or edges. At this point I have wire because I have like a enclosed edges, so we call it wire. So I select wire, then I can select this triangle. Alright, and then we can select the extrude direction. If you remember, the other time I just selected the Z direction because we were just going exactly perpendicular to the face. Now this time I selected 2 points because I'm gonna come from here to here, and then that's a different direction. So let me select the first point right here, second point in the middle of this page, and you can adjust the length for that. Check the preview and say OK. Alright, so far I just made this one as well, so I can just see 3D view. I got this one so far. But please consider that these two are two separate solid now, because if you want to see how that one is embedded in this one, you can just right click on that and go to the display mode and, for example, put it on a wireframe. So you see that this is my main slope and this is the other edge. And as you can see, this is kind of inside that, but they are not connected. So the next step for us is to make that connection happen and then make them as a one unit system. Alright, so to make this connection, we can use this option called fuse. So if you are in a solid tab, you can click on the fuse, and then you can fuse these two solids, solid 1, which we call it master solid, and then the Boolean 2. And you can get the preview. It's gonna be exactly the same thing. Merge faces and OK. Alright, so now you see when I'm selecting this, everything will be selected to each other together. And if I go and hide or put it on a wireframe, you see that these two are exactly the same model. Alright, shading and edges. Alright, so far so good. Now we are done with the creating the geometry. So steps in Midas GTS is most of the time, first we create the geometry in 2D or 3D. Then the next step is start meshing. So for meshing, we need material property, ground properties, and if you have any structural property like a beam or pile or something, then you can also assign it to the mesh it and then model it in your model. Okay, so next step will be meshing. For meshing, you remember in the first model that I showed you, we had different mesh size. Let me bring it here again. Look at this. In the middle we have smaller or finer mesh, and then the outer side we have like a coarse mesh. So how to do that? There is very simple steps. We need to define the mesh size all around these edges. So for that reason, I go to the top view, and let me select different part of the structure. Going to the auto mesh and map mesh. So as I said, again, all these options are available for you from the main menu as well. So it depends on how do you feel more comfortable with the modeling. So you can go to the mesh, and then you now control mesh size and all those. But I feel more comfortable if I come to the auto mesh and then select the options from here. Okay, so I go with the edge mesh sizes. Select the edges. I select this edge. Let me see how we're going to make it. Okay, so and then there are different methods for applying these mesh sizes. Let me show you. As of now, I want to just go with the internal interval length, which means the exact length of these elements. So I put the 1.5. All right, so let me just go with the linear grading, and then select these two elements. Select the edge, will be this one and this one. So I start from 1.5 at the left, and then to the right will be 3.5. Get the preview. Okay. Apply, and the same thing I do for this part from here to here. Go with the 1.5 and 3.5. Get the preview and apply. And now for the this edge here, right there, I just select a linear interval. Select these guys. These, and these as 1.5. Okay, and okay. All right, so we mesh these, and then the rest of them we have option to control the mesh, or just leave them as they are, because later on also we have option to create those assign those sizes to them. I will show you how. So okay. To complete the mesh, you have a couple of options. You have for solid, you have auto mesh, you have map mesh, and you have edge volume mesh. So for now, I want to use the map mesh, auto mesh. So for that one, this will make it so easy for me. Select the solid, is that part, and then dividing the size. I said I go with the size 4. And this is the attribute that we just defined. But here's the thing: if you forgot to define your solid, or in case that you didn't assign this attribute, you can simply define it here. Just right click on this click on this option, define it here, define the material. Everything is ready for you. So just one thing, I gotta do some changes here because the direction of the edges wasn't good. So let me just change the delete mesh control for so when I'm selecting these, okay, and then saying that show me the mesh set, I see that these settings are not as I was expecting. I was expecting the other way. So that's why I'm trying to just change that. So going to the mesh and the mesh control. So okay, I can delete this. I can delete the other one. All these meshes along the. Alright, and then finally this one. Alright, so I can again I leave the rest of them as they are, and then again I go ahead, go with the internal. Left will be 3.5 and this time will be 1.5. Select the edge. Okay, and then let me get the preview. Alright, that's what I want, because you know this time I have like a smaller or finer mesh around the this edge here, so that's exactly what I'm looking for. So apply, and this time the other way. So again the direction is that side. So what I do, I just change the direction, 1.5 and 3.5. So the good thing is you can simply visually see what you are doing here, and if there is something wrong, you can simply change them. All right. So this is done. Let's go to the auto mesh again. Select the solid and select the size as 4. Attribute is clay, and I call it practice 1. Check it. Everything is good, and okay. Alright, my model is meshed as I showed you in the beginning. So now is the time to apply the ground supports and you know, set up the analysis. Alright, so to set up the grounds, you can simply go to the analysis tab here and use one of these options. So here you have the support where you can simply select the mesh sets, select the nodes on the mesh, and then give some degrees of freedom or constrain some of the degrees of freedom, and then assign it. This is one way. There's another way which I prefer and is make it easier. It's using the ground support. If you click on the ground support, it automatically considers all the mesh sets in the model. Here we have only one, so everything is okay. And then apply. Oh, let me define the boundary set. I call it support. And okay. So by the ground support, it automatically applies the relevant supports to the locations that is required. All right. So it's just done everything quickly, and I don't need to be worried about any of those. All right, so let me turn it off. Whatever you don't want to see, you can just simply uncheck it, and it goes away. All right, so we are done with the support also. Now is the time for defining the self-weight. All the loads that applies, including the self-weight. Again, when you are on the analysis, you can simply select the self-weight. The icon is here. I call it self-weight, and always the self-weight in 3D analysis is in a Z direction and is in -1 because it goes downward. But by the way, you can always see the global coordinate system in the right bottom corner, so you understand that this is the Z direction upward, so we got apply -1. When it comes to the 2D, normally the 2D in GTS is in the XY plane, so always for the self-weight we go -1 in the Y direction, but here it's 3D, so always -1 in the Z direction. Alright, so the self-weight is also created. Now let's set up the analysis cases. So technically here we are running the slope stability on this model for the self-weight. Again, under analysis, you can go to the analysis and then analysis cases, or you can just simply click on that option here, add. All right. See what options do I have here. we have two options, slope stability SRM, which is strength reduction method, or SAM, which is kind of similar to LEM method, a combination with the finite element. For the SAM method is available for 2D analysis. So for 3D, as I mentioned in the beginning, we have to go with the SRM or finite element method, which is pretty accurate method, but it takes a little bit longer time to perform the analysis. But the result is very accurate and very reliable, way more than what you can see by LEM methods. Okay, so I selected this, I call it SRM, and then always we have to control our analysis setup. So right in front of the slope stability SRM, we have option for analysis control. Click on that and it gives you the option to select the maximum number of trial, because finite element method is a trial method. So you can simply select this maximum number of iterations, and yeah, all these are good, and say OK. Initial water level, we can set it up as a 0. Okay. Alright, that's done. Now you see whatever we modeled here, the mesh set is showing up here. I call it practice 1, right? So you can simply drag it and drop it here. Again, for the boundary, we define the support. I can drag and drop it here, and the load cases is a self-weight. I can drag and drop it here. But not always you need to drag and drop these things, because if you check these options on the analysis model, always the initial element and initial boundaries, by default, all of them are selected. So doesn't matter if you bring these two guys in the right activation box or not, because they are already selected. But if you want, you can just simply do that. It doesn't hurt. And then for the load, we just added the self-weight. So if you have any additional loads or surcharge loads, so you can simply add them as well. So okay, we are ready for this one. Analysis cases is set up, and now we can just perform the analysis. Run the analysis and get the results. So for that, I can just hit the run and select it and say OK. But as I said, the 3D slope stability analysis is a time-consuming analysis. So it takes time to run the model. So to save time, I have the model analyzed for you. So let me just bring it up, and then together we check the results. By the way, if you have any questions for me, please type it in and I will be answering those. Okay, so this is the model. This is exactly the model that we got. And let's go to the result. So this was analysis, and now we're going to the post option, post tab for the results.
Estratos. Estratos, ¿cómo se dice? Layers.
Okay. Let's check the result. First of all, when you come to the result, you see that there is a factor of safety provided for you. Always when we do the slope stability, we get the safety factor, because that's what at the end of the day we need. So you see for this model, the safety factor is 1.58. So it seems that is good enough. Actually, depends on the code or the situation, but it's at least above 1.5, so it's pretty good. If you want to check different things on this model, for example, strain. So strain probably is important. You can understand that the wear has the largest strain. So technically, strain in this model shows the displacement of those elements. So we can somehow understand that where might have has the most possibility for failure. Alright, so you can check them in the different directions. Alright, and if you want to see them in the different shapes, for example here, you can go to the post command, change them. For example, you want to see the mesh sets, you can see exactly what's going on here, and then the gradient to make it more smooth. If you want to cut through, you can simply use these, or just using the ISO surfaces, show you exactly which surfaces have the same amount of stress for strain, for example. And if you want to see the deformed and undeformed shape, so you can simply select it, or just deformed or undeformed. And you can give the scale factor to, let's say, see it better. Say apply, or maybe something larger than that. So kind of you see that how is the deformation. All right, by applying this, increasing the the scale factor. All right, so this is what we get from the slope stability analysis. So I see a question. Okay, I see that you guys have the microphone installed. Just let me open it. Giselle, can you hear me now? Hello?
Yeah.
Giselle, can you hear me now?
Yes.
Okay, perfect. So yeah, go ahead and ask your question. What do you mean by how many more layers we can create?
For example, if I have another kind of soil, how create?
Okay. Oh, okay. So let's say here we just model everything in one layer. This is your question. Let's say if, for example, you have clay on top and then you have sand in bottom, something like that, right?
Yes.
Okay. Yeah, that's pretty easy. Let me just open the other model for you. It's very easy to create such a model. So let me just delete the mesh. Go into the mesh and delete this part. Alright, but still I have the geometry ready. So solid, come back. So what I do, I just create an additional layer for you in the bottom of this page, and then apply 2 different layers. Is this what you're looking for?
Yes.
Okay, sure. So let me make that one. We go to the surface. Oh, let me go with the curve, creating one from here. Oops. 3D line from here to, for example, here. We'll go from, oops, again 3D line from here to here, for example. Okay, and then I'm gonna extrude that one, solid, extrude it, extrude the edge, this edge, and go 25. Oh, 5. If you remember, the size was about 5, and I call it layer. Select the direction. I go with the Z direction, and that's okay. I select it. So now what I can do, I can just divide the solid with this plate. So I go to the divide solid, I select this, and I select the surface, that surface, and alright, say okay. So now you see I have 2 different parts of solid. Hey. Okay. No. 3 points here, here, and there, and do the original shape, do the tool shape. Okay, and okay. All right. Now we got 2 models. Now if I go to the solid, I have 2 different models. So this is one part. So I assume this part is, for example, the clay, and then in the bottom part I have different layer, and this part also different layers. So let me just define different go to the auto mesh and creating the mesh. For example, this part in the top, I select it, I give it the size 4. Alright, and before that I'm gonna just ensure that there is nodal connectivity, because whenever you have 2 solids or more solids that intersecting each other, you have to ensure that they have duplicated surface to each other, because if you don't, later on you come up with the problem that there is no nodal connectivity between those elements. So for that one, let me go to the solid and check the duplication and apply, and you see that there are duplication here, so I feel safe now. I can go ahead and check them. If you want to see what I mean exactly, let me put it on the wireframe. If I click on that, check duplicate and apply, this is, you see these yellow surface. The yellow surface means between the top solid and bottom solid, that surface is shared. So it means any type of mesh that the top one has, in the border, it's gonna share exactly the same thing with the bottom one. All right, I don't want to make it that complicated, so let's do it quickly. All right. Alright. Okay, so we go to the auto mesh and select auto mesh again. Auto mesh solid, select the solid. I select the top part, going with the dimension of 4, and this time I'm selecting the clay for top and call it clay. Alright, check it, everything is fine, and apply. Alright, this part is done. Now for the bottom part, I want to define a different material. Let's say I'm defining a sand. Alright, and for the material, add it, I call it sand. Let's go with the these values that we got here, and I mean by default values, because this is just for sake of the presentation. And okay, this time I call it sand, and as you see, I'm using a different material, I mean ground properties for that. Select, and then check it, everything is fine. I can go even with a smaller size. Let's say go with the size 2. Isn't that good? 4. Alright, and say OK. Alright, so I have 2 layers of soil. Alright, one of them is sand, one of them is clay. And now if I go to the analysis, when I'm just setting up this SRM analysis, as you can see, I have two different mesh set. One is clay, one is sand. So this time I have to activate both of them to ensure that both of them are working together and activated in the model, in the analysis. Okay? Does it answer your question?
Yes. In the case that I have water level, how is it this case?
It's what? Sorry, I didn't understand. Would you please repeat that?
Water level. What about this?
Oh, for water level, here we just define that. You remember? Here we can define the water level. Let's say 1 meter. It goes 1 meter from the point of origin, or 0, 0 that we defined here. And say OK, it's gonna define that. So when we're defining the material property, we're giving two, I mean both for the dry material and also saturated material. Okay, so the software can understand that point. And the water level also if you want to see the effect of the water, that's also possible in the analysis. If you want to see, for example, pore water pressure, how it affects the analysis, you can get those from the
No, claro, tú le pones las propiedades de cada
from
extracto.
seepage analysis, and then bring them in here and then use those pore water pressure.
Independiente, porque en la simulación recién vas a ver. Tú le asignas las propiedades. Se supone que automáticamente debería hacer la simulación. Porque tú le introduces parámetros por tipo de suelo.
No, tú le asignas los tipos de suelo.
Is there any questions for me which I can answer, or are you guys just discussing with each other?
No,
¿Quieres decir algo?
you can continue.
Okay, yeah, all right. In terms of modeling and meshing and then changing a mesh set, or if you want to change the material property, that's very easy. We can do that. I can show you in the different tutorials. But for now, I prepared other models for you, which, because I really didn't know what exactly you do for your project, what type of project you have. So I prepared different type of project to, match more with your work. So in this model, I have different layer of soil, as you can see. So, and also we have anchor bolts. You see this, the nailing. These nails, you see them here. So they are like a nail the soil to the rock behind that. All right. So this is also done, and then I run the again slope stability analysis and got the result. For example, safety factor came up to be 1.36. So all the steps is exactly the same as the other one, but the point is in this model I gone with the 2D analysis. So just that's the only difference. But you can simply model them as a 3D, similar to what I showed you. And I got one more model for you, this one. This is again in the 2D analysis. We have different soil layers, and what we have here, I use the SAM method. As you can see, SAM for two different methods of SEM, with the polygon and with the circles. I mean circles or polygons, which represent the failure surfaces, and I can show you those, and also with the SRM. And you see that the safety factors are provided for all three methods, and they are pretty much similar and very close to each other. So it shows the you can check the accuracy of models with different methods. And if I show you, for example, for the circular, we used this method. Let me just turn this off so you can see them better. So this was the area possibility that these guys there's failure surfaces, and when it comes to the polygon, this will be the failure surfaces, and 2 and 3. So the possibilities that they happen is shown here. All right. So as I said, these methods are available for you in GTS. You can model both in 2D and 3D, and completely depends on the type of project that you have and what exactly you are looking for the outputs. So if you have any question for me, or you want to see a certain output, please let me know, and I just show those to you.
Any question?
I have one question.
Sure, go ahead, please.
In this case, you draw the structure, but if I wanna import, what can I do?
You want to import from DXF, for example, from AutoCAD?
Yes.
Okay. So let me just quit this model, and I prepared actually one model for you. So let's say this is, you started the project, you wanna import the model from AutoCAD. So what you do, you can just go to the File, Import, and select DXF. So the DXF that I have is 2D actually. So I select it, select AutoCAD 2D, and I go with the desktop and then GTS for DXF. So I select main and apply, and this one shows up here, and then say OK. So I have my edges here and the curves here, okay, and then I can work with it anyhow that I want it. So this was a tunnel project actually. So you see the tunnel opening with the anchor bolts. Okay, so if I want to extrude this, if I want to make it 3D, so I can simply do exactly the same thing that I showed you earlier. Is it clear?
Pero acá le asignas a cada estrato, o sea, a cada tipo de suelo igual.
No diferencia, pues, o sea,
No entiendo tu pregunta.
Just is this I mean is this answer to your questions, or I misunderstood?
In the case of 3D.
Okay, okay. So I don't have a 3D model to open it for you, but if you guys have any 3D AutoCAD, please send it over to me. I open it for you. It's very easy. It's exactly the same thing that I did here. But the point is, in AutoCAD, you have to save the file as DXF format, because AutoCAD itself is a DWG format, but you have to save it as DXF.
Only DXF, or
yes,
also DWG?
No, DWG we can't open it because DXF is a global format that all the structural and geotechnical software I mean are mostly can communicate with. So it should be DXF format.
Okay.
And then the point is, you can also save them as a different in a different layers. Okay. Okay, so for example, I want to extrude this solid, extrude. I select the wire for edges. Yeah, you can select them all and then extrude it like a 200. The direction will be this one. 200 is a lot, so what I do, I just go with the 10. Alright, and okay. So you see, I can create such a thing if I want to make it 3D. But if I don't want to make a 3D, I mean, for example, this was the edges. I didn't want to select those edges, so let me just make this. Alright, and then 10 and apply. The direction will be this one, Okay, and okay. All right, so this will be my technically my tunnel. So I just didn't extrude all of these, so this one is just missing. So you see, you can just bring in the 1D and then make them as a face, or make them as like a 3D, completely solid, and use them in your project. But if you have your 3D model in AutoCAD, that's also very simple. You can simply import it here. As I said, if you guys share your 3D AutoCAD file with me as a DXF file, I can just import it for you. That's very easy. All right. Do you have more questions for me?
No.
Okay, perfect. All right. I